Well, thanks for coming out today, everybody, and joining us for our session, Enhancing AI with Events and Event Store DB. I recognize a lot of you folks that dropped by the booth today in the past few days. If you have not, I'm excited that you decided to join us. Thank you for coming. Now, before we get started, you're probably looking at the screen here and you're saying Event Store. Interesting. Well, this guy's wearing a maroon Kurrent shirt. What is that about? Well, we're actually very excited today to announce that Event Store is evolving to be Kurrent. We're going to be using our new branding that was just released this morning. You are all the very first in the world that get to hear a talk. I'm the first one that gets to deliver a talk. No pressure, right? We're all friends here. Yeah, that's a joke. You can laugh. It's okay. Anyway, so I recognize for a lot of you, this is probably the first time you're hearing about Event Store DB. I'm going to try and change my language to be Kurrent and Kurrent DB and the Kurrent data platform, but I'll probably slip up a few times. Just know we're referring to one and the same product. Okay, so if you saw us upstairs, we are the event native database that you know and love. So my name is Tony Young. I'm a Principal Solutions Architect on the Field Technical Services team here at Kurrent. That's a mouthful that basically means if you are looking for a customer-facing professional services architect to help you understand where Kurrent can fit into your tech stack, you're probably stuck with me. You can find me up on LinkedIn there. Quite happy to connect with you all and answer any questions that you may have or help you get started with event sourcing, event-driven applications, with the Kurrent data platform and event native database. Now, event native, event sourcing, events, these things might be new to you in your organization. In fact, about a year ago, I started at Kurrent after spending most of my career in the SQL and relational world. Now, in SQL and relational world, we talk tables and rows and columns and indexes and keys. So here at Kurrent, we kind of flip that on its head a little bit, and we start talking about events and state changes and how that's different from state. Okay, so one of the things that we're going to do today is we're going to talk a little bit about events and state. How are they different? How can we store data? So for those folks who don't know, a little bit of an introduction here to event-based systems and working with events. I apologize for those of you that are well versed in this, and be a little bit of a review, but we'll give you some information, some examples to kind of set the stage for what we'll get into next, which is the Kurrent data platform, what it is, how it works, and from there we'll get into the sample project we'll be looking at today. It's called the Loans Project. The little sample application that is event-driven, works on our platform. From there, we'll talk about how we can enhance AI with events, the real meat and potatoes, right? Why everybody came here, AI. So we've got some super cool things to show you with how you can use events to further your organization's AI initiatives. Very happy to show that off today in the second part of our demo and talk through the value that events can provide to your AI initiatives. After all that, if you're not already bored of me, maybe you will be after we start talking through some questions, but I'm happy to spend as much time to answer as many questions as possible. You can find me outside afterwards to answer anything we don't get to. Now, if you have not already, please see Kat at the back. Kat will get your name into the raffle where we'll be giving away a couple of t-shirts and sweatshirts at the end of our presentation today. So let's talk a little bit about data models. So data can be stored in a couple of different ways. Most of us start our careers, at least I started my career, looking at state-based systems. So in a state-based system, we are interested in storing, usually in a relational model, rows with columns of data that represent the state of a thing. The state of my order, the state of my customer record, the state of my loan request. And with state, every time we make a change to that record, every time we update it, delete it, we lose data, we lose information, we lose context and granularity. Now sure, we can do things like snapshots, CDC, we can constantly append rows to our tables instead of doing updates and deletes and things like that. But our history is really not an inherent capability of these state-based systems. MongoDB, DynamoDB, Cosmos, they all love to tell you, hey, you can do event stuff with us. But at their heart, they're still concerned with state. The best you can really get to is updating attributes of our business objects, making a copy of that data, a more complex stack, right? Doesn't really fit purpose-built event-native systems, which is really where Kurrent plays. Now with an event-native database, we're really looking to store historical events that take place as part of your business workflows. Tony Young opened his customer account. He updated his address. He put a phone number. He put several different email addresses to try and fake your marketing algorithms so he doesn't get spam, right? All of these kinds of things are events that happen in the workflow of my customer account management. So it's a really efficient data model. We're storing the change that happens, not the state, but the change, only the changes. It's highly granular. We have lots of individual data elements stored inside of our event, right? We keep track of those, and this represents really the full history of an object. So a couple of real-world examples. I don't know, do we have any sports ball fans here in the audience? I'm from Canada. I don't really do American football. We have the CFL, Canadian Football League. I don't follow that sports ball either. But if you are a sports ball fan, you probably know the score of our Super Bowl game last year. Sorry, 49ers fans. But the state of our game is represented as the score. That's the state. Who won, right? But if you only look at that state, if you only look at the score, you're missing the full context, the full granularity, all the plays that happened on the field, the interceptions, the touchdowns, the fumbles, all of that stuff that makes the game exciting. We miss all that information if all we do is focus on the final score. Another example here, dinner. Right, my favorite topic of the day, what's for dinner? Pizza, one of my favorite foods. How much bacon can you fit on a pizza? Anybody know the answer? I don't know. I ask for lots of bacon on my pizza. So if I'm looking at this pizza that comes to the table and I see lots of bacon on it, I'm happy. But I don't really think too much about what went into making that pizza. I don't recognize that there are 12 individual steps. In fact, if you're a pizza maker, you probably realize there's far more than 12 individual steps to make a bacon-filled pizza with so much bacon that you can't even pick it up because all the bacon falls off. But anyway, the state of my dinner is the pizza. It's all the events that make up making that pizza that really gives me a lot of information about it. What temperature did I cook it at? Which spices were in the sauce? How long did the dough rise? What type of cheese? We don't get any of that information unless we store the events that we used when making the pizza. Now, when we're talking about events, we're talking about business events that happen naturally as part of our business workflows. We're talking about things like a customer submitting a payment at branch. We're talking about an action as part of our workflow that causes some state changes, that state change that we're going to capture. These things happen all the time in your business workflows. Save them, use them. They have so much information to offer. We're not necessarily talking about things like button clicks, sensor values, although there are some industries where that is the workflow, right? I'm opening a valve. I'm setting a pressure setting to, 1.21 gigawatts, for example. In those industries, those would be considered business events, but typically those are more actions that happen, through the course of somebody doing a thing. We are really interested in those state changes that are happening. Now, as I mentioned before, lots of databases will tell you that they can do eventing, that they can handle events, work in an event-native way. Well, we here at Kurrent build a purpose-built event-native data platform where business events are immutably stored and streamed. We're concerned with data from origination through to destination. The creators appending events, writing events to Kurrent. The consumers downstream. We are streaming those events through a subscription-based model, through a read-based model, and through a connector sync-based model. So why is this valuable? Why do we get value here? Well, with Kurrent, we're really trying to support and bring together the business and the IT teams. And that can be tough sometimes. Constantly changing requirements as the workflows change. Brand new tech stack, lots to work with, lots of demands on everybody's time, lots of systems to use, lots of things to learn. But with Kurrent, events are keeping our data unchangeable, keeping our data ordered, so the order in which things are appended to the database is very important, because that is your continuous, globally ordered event log. And it's fully auditable. It lets us time travel. It lets the regulators call you up and say, hey, Tony made some fishy trades yesterday. Can you play those back for me? How did those fishy trades get past your ISO office? Let's talk about that. Right? These events are full of highly granular data. That highly granular data has tons of business context, and storing those events with that highly granular data means that you can remove limits on any downstream usage of that data. How many people here know what every element in their downstream data warehouse means? The value of it, the context of it. I don't see any hands up. And that's right. As we move data downstream, we transform it. We take it from the ODS, we transform it into another ODS. We transform it to a warehouse. We transform it to an intermediate store. And we transform it and transform it and transform it, and all of a sudden, we have no idea where it came from, we have no idea what it is, and we've lost some data along the way. How many people in here have ever implemented a business process or a business workflow that never changes? I also don't see any hands, right? The business changes and adapts to the customer, to the marketplace, and you as tech people need to do the same. We all have to change, right? We get something in place and there's a change order that comes down the next day. Hey, we found a better way, a more optimal way, some other way to look at it, some other source or some other destination to use, right? So we can be really flexible to these workflows. We are storing all of the events. We can simply replay them from the beginning into our new system, through our new rules engine, to our new target. We can future-proof. AI exploded on the scene last year. We're all super excited to use it. But where's the data for it going to come from? If all you're tracking is state, all you can do is feed what you know right now into your LLMs. That's all you can use to train your ML models. Your BI warehouse that you have to stand up for, whatever Tableau's next thing becomes. Your DI, EI, EIO technology, whatever that happens to be in 2 years, 5 years, 10 years. Imagine if you could feed it everything you've ever done with your business instead of just what you have right now. So let's remove those limitations. Let's look at events. So let's dig into some code. How many engineers in the audience? How many of you know Python? How many of you are going to throw something at me because I said we're going to do something with Python? I chose Python as the implementation language for this demo because it's really readable. I didn't choose it because it's the only language you can work with. In fact, if you stopped by our booth, you probably heard me say we have client SDKs for Java, .NET, Python, Go, Rust, JavaScript. Okay, so we are very flexible in terms of language. I chose Python today because it's super easy, super lightweight, and when you all go home and say, oh man, I really want Tony's code because it was super awesome. Spoiler alert, it's not great code, it's code. I'm not an engineer. But it is readable and it's usable right out of the box. You can install it on any platform. Okay, so that's why I chose it. But to give you a little overview of our sample system here, we're going to implement with Kurrent an event-native loan request system. So we chose loans because most people have interfaced with a financial services institution on some level to apply for some type of credit, a credit card, a student loan, a home loan, maybe, Larry Ellison's in the audience and has yacht money but needs a top up to get his latest yacht, I don't know. But a loan is something that most people are familiar with having applied for in their day. Now, if your bank is like mine, there's about 10 bazillion steps that you have to go through in the process, and rightfully so. This Tony guy's kind of shifty. We don't want to necessarily give him all that money, right? You need to make a critical evaluation of a person and their circumstances in order to decide if you're going to grant that loan request. But we're going to break this down into 4 main steps. The first step I have here in the top left-hand corner of my event-native loan request system is the loan requester itself. So this would be a piece of code, a website, a mobile app, something where a human being is sitting down and applying for a loan, putting in their personal information, your name, your address, phone number, etc., how much money you want, where you work, how long you've been there, that sort of stuff. And once I get all my information in there, shoe size, age of my firstborn child, the goal that I'm going to put out on the doorstep so you'll approve it, I click the submit button, and that's going to generate a loan requested event. So my loan requester is going to submit loan requested events. So for the purposes of our demo, because you already know about me that I talk too much, I wouldn't want to stand here and type and try and talk through. I'm going to use a super cool tool called Shadow Traffic. Shadow Traffic, written by Michael Drugalis, really great at building mocked up data sets. And we're going to put a little rate limiter on there just because I don't want the demo to fly so fast that you can't read things as they're happening. So every 6 seconds, Shadow Traffic is going to throw in a new loan requested event for us, and that'll happen in the top left screen in my demo. Now, just because I request a loan doesn't mean the bank is going to grant it. There's things that have to happen behind the scenes. Well, one of the great things about Kurrent is that we don't just have this giant topic of events, we have a concept of fine-grained streams. So fine-grained streams you can think of kind of like an index on that immutable log, that collection of every single event. And fine-grained streams allow me to pull a subset of events out of my immutable log very, very quickly. So I can subscribe to streams, say, per loan request, or for the category of loan requests, the type of events, like loan requested events. I can build my own by correlation ID, so if I want to relate together a string of events, we can embed a correlation and a causation ID property. That would allow us to break that down even farther. We have a custom engine built in as well, where I can take out all the loans that are applied for in the United States, or all of the loans in my native Canada. We can do some analytics on those as well. Okay, so very, very flexible in the streams that we use in order to very quickly access that subset of events. So my credit checker here in the top right corner is going to simulate a credit check. It's not going to use Equifax's 400 to 900 rating system, which I can never understand. It's going to be a number between 1 and 10, randomly generated, 1 being, alarm bells go off, sirens, do not give Tony the money, 10 being, hey, this guy's credit is perfect, of course we'll give him the money. And there'll be a meaty middle there where, it's kind of questionable. I don't know if I can automatically decide to give Tony money. But that credit check will land back associated with my loan request as a credit checked event with a score. In the bottom left window, you're going to see a component we call the loan decider. Now the loan decider is going to be subscribed to the stream of credit checked events. Once a loan request has a credit checked event, we can combine that credit check with our loan requested event that has all our application information, and we have enough to decide if Tony's credit score falls between a 1 and a 4, automatically deny. If it falls between a 8 and a 10, automatically approve. If it's in that 5 to 7 range, or sorry, 4 to 7 range, we want to send it off to our fourth component, which will sit in the bottom right corner there, and that is the underwriting app. Now the underwriting app is a little bit special. It's listening for loan approval needed events, and it's going to present what we call a read model to a human being to make a decision about whether to approve or deny that loan request. Now, a read model is just a really fancy word that means I'm going to build the state of my loan request and present it to a person in a format, a non-event based format for them to use. Okay, so that's what's going to happen there. And again, because I talked too much, we're going to use automated underwriting. We're going to have the Python script just decide whether to approve or deny the loan and pick a random name. And from a system architecture perspective, this is really simple. I have my 4 applications on the left-hand side here. The user interacts with the loan request system. All of these 4 lightweight Python scripts are going to interact with Kurrent DB, where we're going to perform OLTP type actions. It's going to be our operational data store, real-time information, and we can feed them downstream into our BI platform, our analytics platform, into a custom app, which I'll show you as well. Okay, so let's jump in here and see the loan project in action. Now, if you dropped by our booth, you probably saw running in the background on my laptop, some flashy dashboard, which I'll show you in a second. But here's the code actually operating right now. In the top left corner here, I have shadow traffic running. Shadow traffic is generating loan requests. Those loan requests are being written to Kurrent DB. So as a new one is generated, it is appended to the database as an event. We're storing that JSON as an event. In the top right corner, our credit checker is listening for loan requested events. It is pulling that information and then simulating a credit score. It's then appending a new event, a credit checked event with the credit score. So you can see those faked out credit scores and faked out social security numbers there, national ID numbers. In the bottom right component is our loan decider. It is also connected to Kurrent. It is subscribed to the credit checked event type stream. So every time it receives a credit checked event, it's going to find the loan request ID, and it's going to then go and pull the entire loan request and generate state and look at it and make an automated decision. Can I approve? Must I deny? Do I not have enough information? In which case, I am sending it over to my fourth component by appending a loan approval needed event back to Kurrent. And once we receive a loan approval needed here, our underwriting app is going to pull, again, recreate state for that loan request, and it's then going to present that as a read model, aka a screen where the loan officer, the underwriter, can simply read the details of the loan request and make a decision. This Tony guy, I don't know. Don't give him money. You never know what he'll do with it. And then it's going to, you would be able to approve that loan or deny it again. Because I talked too much, we're allowing some automated underwriting to take place. When you look at the sample code, you can turn that off though, and you can go in and interact with it in real time. So all this is flowing through Kurrent DB. We also have this TypeScript dashboard written here that is showing our constant flow of loan requests, credit checks, loans that require approval, approvals and denials. Okay, so as these events are flowing in real time through Kurrent, this TypeScript app is also subscribed to that same stream of events, that same set of events, and is using them as those apps are as well. Now if I look inside the database, I can actually see the suite of events that make up a particular loan request. I'm separating them into a fine-grained stream by loan request ID. I can take a look at each of these events. You notice there is an event number. That is the order in the stream in which this event falls. I can see the JSON associated with my loan request, as well as the metadata. I can see the JSON for the credit check, the loan approval, and whether it was automatically approved or not. Okay, so all this is happening in real time. No wool over anybody's eyes. All right? So, what's the big deal here, Tony? Let's talk a little bit about AI. Now, I had the pleasure this summer of playing with OpenAI and ChatGPT on a much deeper level than I had ever before. I got to go and figure out, hey, how can Kurrent make use of AI? How, and why did I choose OpenAI? Well, quite honestly, it was the one that I was familiar with. But there are all kinds of LLM providers these days, and every company is sitting there scratching their head a little bit, trying to figure out not just what to do with AI, what are we going to do with this technology, but we're also facing a lot of other challenges. AI workloads need quick and efficient access to data, straight up. You cannot have a human being sitting there asking a question and it takes several seconds, tens of seconds to minutes to return a response. That's pointless. We get bored. I get bored anyway. And real-time data is important, but that data, as we know with today's system design, system architectures, is often locked away in ODSs. It's protected. It's walled up. How many of you let your, what you would consider your real-time applications that run your organization get accessed by other applications such as BI, analytics, ML, AI? Anybody here? Nobody. I've yet to meet an architect that says, sure, you can attach your random analytics engine or reporting engine or ML engine or whatever to my highly performance sensitive credit card processing application. No problem. We're cool with that, right? No, we're not. Now, the AI tooling environment is also in constant flux. I lived this summer to a T. I needed to figure out how to use OpenAI's Python libraries. Every example I could find, this is how I program. How to do X in system Y with programming language Z. All the examples posted are out of date, every single one. The tooling had changed. The library was at yet another point release, and what worked a month ago, 2 months ago, no longer works. So I'm trying to learn this AI concept. I'm trying to learn how to interact with this set of tooling to get it to work. I'm trying to figure out how to get data prepped and groomed and transformed and ready. I'm trying to figure out how to apply security to it. I'm doing all this work to try and figure out how to make this AI thing work and figure out what to do with this data to apply AI to my business. It's a lot. It's too much. And that, I think, is why a lot of organizations have kind of stalled out in AI. I was also finding that 90% of the time that I was spending just working with machine learning, put aside LLMs and things for a little while, was spent trying to get data in the right format to feed to those models. 90%. I confirmed this with some of my friends that work in machine learning roles. 90% of your time. So if I'm spending 10 hours on a project, 9 of those hours are spent getting data ready, and only 1 hour is spent. That's a tremendous waste of time. So we need to do something better. The bottom line here, really, the big struggle is getting data to our ML models, to our LLMs, quickly, efficiently, with as little behind-the-scenes work as possible. So why are events useful here? Why do we think that events can solve this challenge, help with this challenge? Well, LLMs at their heart and a lot of machine learning models these days, are natural language processors. They understand natural language really well. Events, by their definition, are written in natural language. I don't have a C_F_name element. I have a customer first name element. I have all that rich business context that I told you we need to capture through our workflow. And it's all written in plain English or plain Spanish or plain Portuguese or whatever language we happen to be implementing in, right? These are also the natural language of the business, or the way that the business operates. It's a natural fit. How many more times can I get the word natural on a single slide? So that's also a joke. Now, when we look at top-line AI use cases, they kind of fall into two broad categories. There's the category that I like to call the tell me something good, the QCon type use cases, the conversational interface use cases. Things like Chatbot 2.0. How awesome would it be if my bank knew everything about me as a customer of the bank and could answer questions like that without me having to call a call center, speak to a person who has to look up a thing, who has to talk to a manager, who has to do X, Y, Z. Or conversational interfaces to products. How often would it be if I could ask my phone how to use the features of my phone, if it knew those features, right? On the other side of the spectrum, we have things like digital assistants, the Beatles, help, I need somebody type interfaces, right? Any Beatles fans here? I had a little soundbite, but it didn't work on the slide. Things like decision augmentation, RAG tools, right? Really big here. Agents, really big here. Coding assistants. You don't want my coding assistants, let me tell you that. You want a co-pilot. You want a system that can analyze and write code for you. Maybe that's what I need for better coding. So where does Kurrent fit here? Well, at Kurrent, we think we have something to offer with events, sort of in both of these camps. So today I want to show you how we can enable a Chatbot 2.0 with our demo loan database and really basic events. I'd also like to show you how we can play in the decision augmentation space. Imagine if your underwriters who are looking at a loan request could get some suggestions from an LLM on where to further investigate Tony Young's loan application. Check this, it's kind of fishy, this detail doesn't make sense, right? Look here, we want to take this into account with Tony's income and number of dependents. Okay, so I want to show you an example of how we can play in both spaces here. Now, when we're talking about AI, LLMs are hosted up in the cloud. Providers like OpenAI, Facebook, Meta has one, Google, Microsoft, they've all got their LLMs. But organizations are also starting to host their own LLMs internally through things like Llama Server. Now, my examples will be with OpenAI because that's what I was playing with this summer and getting ChatGPT to kind of talk to me. But we did also experiment with Llama Server. And while the performance sitting on my laptop was terrible, it does work really well if you can get a Llama Server set up with an LLM of your own, train it yourself. Now, the data workflow that we're going to use here is going to be fairly similar for both cases. We can either aggregate state, and we can present state and then ask a contextual question, or we can take the raw events as stored in Kurrent, pass those over as system context, and then ask a question. I'm going to show you how to do both, just for kicks here. But know that one requires a little bit of transformation, aggregating state, which you would already do in an event-based system, and one requires none of that. Simply pull the raw events, push them across with a little bit of fine-tuning, ask your question. So we're going to change our system architecture slightly. We're going to add a chatbot component here. We're going to modify our underwriting component. The chatbot component, we're going to allow a human being to interact with and ask some questions. And our underwriting component and our chatbot are going to access an external LLM as well as access events from Kurrent. So as we go through pouring a little bit of AI on the loans project, remember, events are written in a natural language way. They are what happened in your business workflows. And our LLMs are natural language processors. That's why they fit so well. So let's look at how we can use these together. So I'm going to come back here into VS Code. I'm going to edit my config.py, and I'm going to turn on underwriting AI suggestions. And then I'm going to come back to my underwriting window here. I'm going to kill it and reload it. And I'm going to allow the underwriting app to start pulling loan requests to present to an underwriter again. But this time, what we're going to start to see is that we're going to pull that loan request, we're going to calculate our read model, rebuild our state, we're going to present that to our underwriter, but this time we're going to request a summary from OpenAI. And we're going to say to OpenAI, hey, here's what's a good credit score, a moderate credit score, a bad credit score. Don't worry about the timestamps when people apply, that's not really valuable to us. Here's all of the state of our loan requests. Tell me areas that I should investigate further, and provide me a summary of these key areas of the loan application. Oh, and by the way, put it in JSON format so that Tony can parse it as an event and put it back in Kurrent, and it can look pretty on the screen. Now, how fast did that happen? That was like a response in maybe 4 or 5 seconds, right? So our underwriting app has pulled that entire stream of events, reconstructed the state of a loan application. It has taken that state, appended it as system context, sent it off to OpenAI, given me back a response, boom, response received. Here are some areas, or here is a summary of the credit score, the employment history, the loan to income ratio, marital status, and some areas that you should investigate further. Do you approve or deny this loan? Focusing my attention as an underwriter on what could be more important. Let's look at another case here. So I'm going to copy this loan request ID. Let's say that I myself am, who's this person here? Mrs. Bennett. Nothing like a live demo, right? So I'm going to kick off my chatbot. Now my chatbot here is a little contrived in that ordinarily you would consider there to be hours, if not days, between steps in a loan request process. A human being probably wouldn't sit here, that each of these steps flows in my demo every 5 seconds, right? So that moves really fast. So what I did here is I'm pulling the loan request stream and I'm walking through each event individually, and I'm going to give enough time for us to ask a canned question, receive a response, and then move on to what it would do by adding the next event to the system context and the next and the next. Okay. So I'm going to go ahead and give the chatbot my loan request. You could conceive of your website having knowledge of all the loan requests that I put in by ID or by stream name, and a button for me to click to get some information. Hey, chat with us, right? So you would not have to have a human being take that loan request and say, hey, tell me about loan request, whatever that random UUID is that I can't even read and pronounce, right? So by starting out with one single event, the loan requested event, hey, I think I made some mistakes in my loan application. Can you tell me X, Y, Z about my application? Well, the LLM comes back with a response to my question. I can't give you your national ID. Why not? Well, I told it national ID is PII. That was a piece of fine tuning. So don't ever give that out. But I can tell you the country in which you applied for your loan. If you need more information, feel free to ask, right? What's the next event in my stream. Well, perhaps I log back in and I see, hey, my loan, the credit, you checked my credit, that's cool. What's my credit score? Well, I'm going to feed the LLM my loan requested event and my credit check event. And now I'm asking it a contextual question about that, and it's able to answer for me very, very fast. The next event, loan approval needed. Hey, loan approval needed. Okay, what's the status of my loan request? You know, I'm an end consumer. I don't understand your bank statuses, right? So tell me what that means. And then my loan was manually denied. So, it's denied. Okay, what's the status here? Why? You know, maybe the next question would be, why would it be denied? We don't store that in our simple example, but you can conceive of the underwriter needing to provide a reason for denial, and then asking the LLM to provide that to the customer. And we've answered all of these questions without requiring a live agent, a human being, to pick up a phone and answer, hi, I'm Tony with Acme Bank. How can I help you today? Oh, let me look into that. Let me put you on hold while I talk to the underwriter. All this has come straight out of the database. So, what's the takeaway here? What have we done? Kurrent enhances and accelerates your AI initiatives by aligning natural language events with natural language LLMs. With Kurrent, we can skip data transformation, so we can feed it raw events like what we did during the chatbot use case there, and we can simply provide that as system context. A little bit of fine tuning, ask it a question. If we want, we can use snapshotting or state reconstruction, like we did with the underwriting section there. I have to regenerate state anyway to present it to an underwriter. I can maybe reuse that state and present it off to an LLM as system context with a little bit of fine tuning and ask it a question. I've just enabled 2 different categories of use cases with raw events. Now this fine-grained detail that we're collecting in the event is what's happening in our business workflow. We're putting it to use. We're leveraging the value of all that contextual information. If all I'm storing is the loan request itself, if all I'm attaching to it is a credit score and updating that record, I have lost the fact that there are now 2 separate actions that were taken and 2 separate events generated. All that context is gone. Our fine-grained streams gave very quick, very efficient access to all the information needed to enable Chatbot 2.0 for a single customer's loan application. Fine-grained stream, very quick to access. Get me just those events that are related to that particular loan request. Now we can sit anywhere in your infrastructure. What I'm showing you here is an application that is being used as your primary ODS for your loan request system. Conceive it your bank with thousands of loan requests, hundreds of loan requests a day. Or in your order processing system that is receiving hundreds, thousands, tens of thousands of orders in a day. You can have that primary system operating against Kurrent as its data store, and that data flowing to an LLM, and that same data flowing to a dashboard, and that same data off enabling a data warehouse in real time. Your BI folks will love you. Your call center folks will love you because they don't have to answer as many calls. You can push people to a chatbot. Your customers will love you because they don't have to call in and speak to a human being. They can ask a chatbot. Now the AI tooling environment is still in flux. I don't think that's going to change for some time. I think it's going to be a little while for those interfaces to mature, for the LLM providers, the big providers, to really settle on some solid tooling. And that's okay, we want them to get it right. But Kurrent's clients are tried, tested, and true. We have all kinds of customers all over the world running very successfully in production with our client SDKs, and they have been for over a decade. So you can focus your engineer's time on learning the AI world, learning the AI tooling world, and skip things like vector databases. Skip things like learning how to use this brand new, event SDK and make it work with AI. Our authentication, our authorization, TLS, encryption at rest, all these kinds of security features that you need to keep your customers' PII or their, even their not PII data secure is built right into our platform. So you don't need to worry about having this data exposed in your enterprise. We'll keep it secure for you, and you can use a secure endpoint with OpenAI or Google or whomever in order to get that into the hands of an LLM to answer a question. Now, Kurrent can also be deployed on-prem, in cloud. You can use our managed cloud. You can locate it next to your data so that you can very quickly and efficiently access that data and send it off to your LLM of choice, completing that system architecture we all want to get to, where everything is nice and co-located. So thank you very much, everybody, for joining us today. If you want to learn more about how to get started with Kurrent, the Kurrent Data Platform, you can visit us at academy.eventstore.com. That URL will eventually be updated to the new Kurrent domain once we launch it. You'll find lots of free videos and information in there, training on event sourcing, on how to use Kurrent. You'll find our loans project demo code in there as well. And at this point, I'd be happy to answer any questions you have, either in the room or outside after. Thank you very much.